All right, so the water notebook, it looks like this. It's got a fun gif of a dog drinking some water. So the first slide that you're working on, so slide 2, what water molecules, sorry, are attracted to one another? So you'd click on the raindrop, and it would take you to this. So you'll see that the oxygens and the hydrogens are connected to each other. So you see I have the oxygen and the hydrogens connected here, oxygen and the hydrogens. So it would look something like this. The reason why water does this is because it is polar. So the oxygen is a little bit negative, the hydrogen is a little bit positive, and opposites attract, and that's why they form like this. Slide 3, water is the universal solvent. Define the term universal solvent. So universal solvent, it means that it dissolves more substances than any other liquid. So water dissolves more substances than any other liquid. Here are some examples of that. It can dissolve salt, dissolves food coloring, sugar, baking soda, limestone, Kool-Aid packets, things like that. You put it in water and it dissolves really fast, and that's what makes it the universal solvent. Slide 4, you are to find pictures. So you can go up here to insert, and you could use insert image, and you can search the web, or you could just go into Google, type in all of these and find a picture, or you can take your own if you wanted to do that. The gas one I do not recommend you doing, but the solid and the liquid you can do. So for slide 4, you were going to tell me water is the only substance to exist in all 3 states of matter. So solid, which is ice, liquid, which is just water that we have that we drink, and then gas, which is steam that we see here. Slide 5, you were telling me water has a high surface tension. What's surface tension? So at the surface, there are fewer molecules to stick to since the air is above. This results in a stronger bond to form between each water molecule. These stronger bonds form what is known as surface tension, and it is why certain objects can float on water's surface. So if you were to go to the website, you would see that there is, you scroll down to here, there's a little water bug. It's called a water strider, and due to the water's high surface tension, it is able to skid across the water. There are other organisms that do this. You can also have used other examples besides this one. Slide 6, water has a large temperature range. So in this case, let's start with solid. So 32 or less degrees Fahrenheit, it's solid, or 0 or less degrees Celsius. Liquid, 32 to 112 degrees Fahrenheit to 100 degrees Fahrenheit, or 0 to 100 degrees Celsius. And gas is 212 degrees Fahrenheit and higher, and 100 or higher degrees Celsius. Now, since we're in science, we're using Celsius here, and Fahrenheit is what we use when we're talking about our temperature in our house, temperature outside, we're using Fahrenheit, but normally in science we would use Celsius. For slide 7, solid water is less dense than liquid water. So you are to provide a real-life example and explain what happens and using the statement above for your reasoning. So I chose this picture of some ice cubes in a glass with some regular water. So this is liquid water, and remember, ice cubes are frozen water. So when you put an ice cube in liquid water, the ice floats. So solid water, which is ice, floats on top of liquid water. Since solid water is less dense than liquid water, it floats. So things that are less dense than other things will float. So solid water is less dense than liquid water. Slide 8, you are to look at this map here. And when you open the map, you were able to click on these different points of the, like, that were pinned on the map. So you were going to start with the yellow cities. So you would go down and you click on the yellow city, and then you would look at the top and you see min, max, and average. So you did that for all of these depending on the color. If you need help differentiating the color, please let your teacher know. I know some people may have a more difficult time identifying the colors than others. So what I did here, instead of averaging these out, I just went ahead and put for all of them. Then we can see a more general trend. So for the yellow cities, which are located, zoom out a little bit so we can see Virginia, which are located, over here near West Virginia, closer to the mountains. You have your red cities, which are in central Virginia here, your dark blue, which is Washington, D.C., and then you have your light blue ones, which are all of these. They're all coastal cities. So what do we notice about these temperatures? So if we're looking at, let's go on, so slide 9, you are to notice a difference in the winter temperatures. If you look here, you have the yellow cities at 40, the red cities at 40. Then you have the blue cities are at 50, so they're higher. That's interesting. And then the DC is 30. So, do we think that maybe the coast has warmer winters? So typically, the coast is warmer than mainland. So if we look here, we see a difference of about 10 degrees between these four weathers and these four weathers. Okay, so the temperature close to the ocean is warmer. Weathering. We're going to do 10 and 11 here. So weathering is the breakdown of rocks, soils, and minerals, as well as other man-made materials. What is physical weathering? Physical weathering is caused by the effects of changing temperature on rocks, causing the rock to break apart. So these are things like ice freezing and cracking open sidewalks. Chemical weathering is the erosion or disintegration of rocks, building materials, etc., caused by chemical reaction. So these are your chemical reactions. So 11, you were to just click and drag which picture represented which. So physical weathering is this one. You can see that there's these cracks in the rock here. That is from physical weathering. And over here, chemical weathering. This is called oxidation, also known as rust. This is what happens when metal gets wet and it gets exposed to oxygen. It oxidizes and it causes rust. So don't leave metal things outside that aren't covered in good paint, or they will start to rust. Slide 12, you were to tell me what the percentage of fresh water on the planet is compared to salt water. So 1% of water is fresh water, meaning it's drinkable, non-salty water. The largest percentage of water that we use is for food. So it takes 13.8 gallons of water to make one orange, which is insane. It takes 13.8 gallons. You all probably, a lot of you probably have a gallon or half a gallon of milk in your fridge. It takes 13.8 gallons, one of those full, in order to make one of the oranges that you may have in your fridge. It's crazy. And then for this one, you were to click on the plate, and it makes you a plate, and you are to tell me how many, like, what the meat or the food is, how many ounces you are going to eat, and then you're going to tell me how many gallons it takes to make that. Okay? So you're filling this out. All of yours will be different. For 13, we're going to go ahead and go over it. I'm not going to have a slide for it. Importance of water. What are the pros and cons of dams? So dams provide energy for electricity. They use kinetic energy, and they generate electricity from the kinetic energy. Cons are they may disrupt the natural flow of water, which can affect ecosystems. They also flood areas when they're first made, which completely destroys ecosystems. Um, a good example is trout have to swim upstream, and if there is a dam made in their way, they are not able to go and mate because they're not able to get to their mating area. So dams have cons, and there are some of them.